guys. So this is the lecture series on digital image processing, and today our topic is histogram equalization. And I hope from the last lecture you got to know that histogram equalization is a part of global contrast enhancement. Okay, so you know what is histogram. Histogram is a graph which shows frequency of occurring data in the whole dataset, and it plots the number of pixels for each tonal value. Okay, the definition for histogram is very important. Do note it down. Then if we consider an image Z with Z to tell possible intensity level, means we have Z to tell possible intensity levels in that image, then the histogram of the image in 0 to z minus 1 is defined as a discrete function, that is prk is equal to nk and divided by n. And what is rk? Rk is the kth intensity level in the interval. And what is nk? Nk is the number of pixels in the image whose intensity level is rk. Then n is the total number of pixels in that image. Now, this histogram equalization technique is an image enhancement technique which enhances the contrast of an image by spreading the intensity values over the entire available dynamic range. This is very, very important, the definition for histogram equalization and the formula just I have explained. Okay, so histogram equalization is an image enhancement technique which enhances the contrast of an image by spreading the intensity values over the entire available dynamic range. So if questions comes like what is histogram equalization, please don't skip this statement. Okay, so this is achieved through a transformation function tr, which can be defined by cumulative distribution function, that is CDF, of a given probability density function, that is PDF, of gray levels of an image. Okay, so in my practical session, I have already defined what is CDF and what is PDF. Now, this image you have seen, then this image you have seen. So first A is the PDF and second is the CDF. So now here we face two cases. First case is the continuous case, and this is for intensity level that are continuous quantities normalized to the range 0 and 1. So we are changing the range into 0 and 1, and that is, well, you all know that that is known as normalization. Now, say PRR is the PDF of intensity levels, then the required transformation on the input levels to obtain the output level S will be what? S is equal to TR integration from 0 to R PRW dW. So integration, you all know that is the sum of this PRW. So range is from 0 to R. Okay, where W is a dummy variable for integration, and it can be shown that the PDF of the output level will be uniform. That is, PS is equal to 1 for all s greater than equal to 0, less than equal to 1, and 0 otherwise. If it doesn't fall under 0, 1, then it will be 0. So the above transformation generates an image whose intensity levels are likely, equally likely, and also it covers the entire range. Okay, and this intensity level equalization process results in an image with increased dynamic range with a tendency to have higher contrast. So this is the histogram equation with respect to continuous case. Do remember these equations and do note down their significance. Okay, that is very important. Then we have discrete case also, and in case of discrete quantities, we deal with summations, and hence the equalization transformation will become what? As k is equal to trk, z goes from 1 to k, prrj, and you know prrj, we have just defined, that is z goes from 1 to k, and j divided by n for all k goes from 1 to l. Now, where Sk is the intensity value of the output image corresponding to value Rk in the input image. So these are the two cases, continuous case and discrete case, and both are important because both are part of our histogram equalization. So as a homework, what you do, you as I have already explained how to perform the histogram equalization in OpenCV. So take an image, okay, and just change its contrast or add some brightness, more brightness to it, okay, so that the image will be degraded to a form, to a level. Then try to apply histogram equalization. First case, apply once, and second, apply it again, so twice. So what will be the result after that? Do note that. Okay. So you see, this is an image, original image, and this is the equalized version, that is image obtained after histogram equalization. And this is the means histogram of the original image, and after histogram equalization, you will find a histogram like this. So all the intensity units are equalized now. So that's why the contrast is improved. So that's all about histogram equalization. And I hope you all got what is histogram equalization. Okay, and this is very important for you. And maximum times you will apply this histogram equalization in your practical experiments. So coming to today's question, first question is that what do you understand by histogram equalization? Second question is that how many cases involved with respect to histogram equalization? Okay, so do comment your answer. That's all for today. Take care. Bye bye.